Now we have the name picked and a repository created, I think it's really time we start to pick the technology stack for this project. So when I talk about the technology stack, I'm talking about the planned use of which technologies, which frameworks, which languages that will work across the whole expected range for this product. So across, in this case, mobile apps, watch apps, and desktop apps to a lesser extent. So we're going to look at the options we have, just briefly the options, what the fors and against are, and there's probably a bunch of languages we need to use and potentially a bunch of duplicated code because the world isn't perfect and there's no real true cross-platform everywhere system yet. But we'll pick the core ones and then discuss, the reasonings for, and also highlight why everybody's trying to go cross-platform everywhere and the benefits of that. So the first thing to look at is really picking the technologies we know we want to use. One is Android and iOS. The other is watch apps. And the third is desktop apps. And then obviously web apps are what they are. You make web apps in web technology and your back end is pretty flexible that you can usually blend it in with whatever technology you use. So the main focus of this kind of research now is going to be the watch, the mobile and the desktop apps, which are fairly popular for people trying to say they've got cross-platform languages and tools, but let's dig deep and find out whether we really have and what we're going to pick. So let's just take a look now. Okay, so the first choice really is we have to pick, as I say, kind of a generic, not a generic, more of a cross-platform starting point, a core to our product. So our product has, I'll do a diagram, I think, and then put it on screen. So we have, in a typical project, almost any project, we have a core layer, and there's usually two. There's kind of the core that goes across, well, it can be multiple, but there's the core that goes across absolutely everything. So it's generic things, typically libraries that you might bring in for dependency injection, for logging, for things like that. You want to try and share those libraries across everything as much as you can. So you've got a universal, universal sort of shared code across the entire product range. So that's kind of what you'd probably call a universal core, or that's what I tend to call it, universal core. Then you step up into the realms of your specific application. So in this case, our diabetes app, Blueberry. And we want to have now a core that's shared between the whole of the Blueberry product range, front end, back end, mobile apps, web apps, watch apps. You want to try and get a core that shares across all those. So again, a language or a compiler or something that allows you to write code once and share it across everywhere. So you've got your two cores. And then on top of that, you then typically have sometimes sort of a base or again another core to the specific platforms that you might need, because cross-platform doesn't yet usually go across everywhere. So you might have to have a core to your mobile apps and a core to your Windows apps. You wouldn't usually just have it if it's just for one platform, because then you just put it in the platform. If there's no other purpose of the purpose of the core is to share it across multiple platforms and the whole project. So if you've just got something where you have to write the Windows on its own, then you wouldn't have a Windows core normally. So you've got these kind of core layers, and the point of them is to share as much code as possible. And the core in this case needs to split between, as we mentioned, like a watch, mobile, web, and desktop if possible. So we need to look at languages that can do that. And that is really the driving decision to what we do. There's other factors like how good's the experience developing, how good's the language, how powerful is it. There's a lot of other factors, but a big drive is, can the code be shared a lot? Because when you've got hundreds of thousands, if not millions of lines of code, the last thing you want to have to do is repeat that multiple times. So we need a language that can span across all them. And then on top of that, you usually end up with in an ideal world, you'd have your universal core, which is generic for everything, logging, dependency injection, what have you. Then you'd have your core that's specific to your project across the whole span. And then you'd have just UI in each project. And obviously between core and UI, you'd have more what you call core layers, things that share between everything, but they'd be things like the view model. So you'd have a project for the view models. You'd have a project for your data, maybe for your entity framework, your database access. You might have modules for logic. So I tend to call them modules when they're above core and they're just chunks of individual code that can be shared across everything and linked together. So again, we'll get more into the architecture of this after, but you can think of it as really just what you're trying to do is take as much code as possible, split it across every application, and then ideally, again, the best thing would be a UI that is entirely cross-platform as well. So you have one code base right the way up. But what you tend to find, that's what the people like Facebook, Microsoft, Google are all actively trying to do, is make this universal, truly universal experience that isn't just some web UI on the top layer saying, oh, it works across every platform just because the web's there, but then the back end has to be different for everything, or the language is terrible behind the scenes. We don't really have a true cross-platform experience yet. We're getting very close, but we've got to pick something. So we have those layers where we've got the cores, the modules that build up all the logic in the program, everything about it, everything it does. And then the last little bit that's separate is usually the view, the actual visual experience. And you want to try and keep every bit of code except the visual experience in your shared code, because it's possible right now with what we have. What isn't necessarily possible right now is a UI that does span across everything without too many compromises, like slow to render, debugging experience bad coding languages, things like that. But that's where I feel we're now looking. We're looking for a good cross-platform experience. So I'll talk more about the architecture in a separate video, but I just wanted to give you a kind of overview of where I'm thinking, where we need, a specific language, or what we're trying to look for in terms of when I'm looking on languages or websites that are offering cross-platform. I'm looking for key things like what language are they using, how many platforms do they span, do they have any reputation, what's the debugging experience like. So if we just take a look at some basic facts first, is that means that because of how large our projects are going to be, we do not want to be writing native code. We don't want to write native Windows code directly, then native Java or C++ for Android, then native Objective-C or Swift for iOS. That you don't really want to have to repeat that many steps because it's just going to take too long and there's no need. It's just repetitive. So that means all the native languages are out for all platforms, really, unless you just, we're doing them because we're using the native UI, which is different. If we can reference the shared core across the whole product range and then just do native UI, that's also fine. So if Android could reference whatever native core we use and still use Android's native language, then that would be an option. For example, WPF on Windows could potentially reference .NET Core, even though .NET Core spans everything, so we could use native WPF UI with a shared code base across everything else. So there's situations like that will occur. But in terms of mobile, native Android, native iOS, native Watch, they do not support cross-platform anything. So they're all out. That means Java's out, C and C++ are out, Kotlin's out, mainly because some people will say Kotlin's cross-platform. It's based on Java, it's dead. Debate can rage there, but Kotlin's out for me. That's not even an option. So those languages are kind of out. If we look at some technologies, and we really search, and I've searched around, I've had the Discord chat with everybody. We've looked at what's an option, what can we use, some viable options that I consider actually potentials. And we really only have three. The obvious one to everybody will be Xamarin. Now, this is kind of the only reason for Xamarin being the main option is if you look for, firstly, this cross-platform based language across everywhere, look at how many languages even have existed for a long time and progressed and developed. Out of the hundreds, if not thousands of languages, I can tell you now there's the .NET framework and JavaScript. That's basically it. That out of every language to exist through time, the only ones I've seen in my career to truly develop and continue to develop and to get better and support things and not just be, a fancy in the wind that appears that everybody is the hot word for getting a job, everybody learns it, then it vanishes. That's happened so many times in the last 5 to 10 years. I can't tell you how many languages, how many frameworks have you guys learnt? This is what everybody's talking about. Let's learn it. Let's use it because everybody wants it. And then 2 years later, there's a new thing out. Learn that. You're wasting your time. You're learning development, but you're never becoming a master in a certain area. You're never really focusing deep and learning to use the best of something. And I feel JavaScript until I think it was ES5 was kind of stale for a long while, then it went to ES6, and now it's progressively having new releases. And there's no coincidence there that, you know, Microsoft have got a lot more involved with JavaScript, and all of a sudden it's progressing amazingly. So out of those two languages, I'd say .NET and JavaScript are the two safe bets. They're going to be around for a long while, and JavaScript will potentially evolve into, I don't know, maybe WebAssembly or merge directly with it, or something with that language is going to evolve. Which also means browser technology is evolving to be the most likely cross-platform system where that's what everything runs on, a browser. So they're just my thoughts about where things are going. And what that kind of means is when you search for a cross-platform base code, there's not really many options. There is them too. There's a web-based cross-platform solution across everything, which means your core base is going to be JavaScript, which is for things like Electron, when you see people making Electron apps, like Visual Studio Code's made in it. You've got many others. You've got progressive web apps where, you know, you develop it across. So most of Google stuff, Google Docs, Google Notes, all those things are kind of, they're built on web technology. So they work across everywhere because they're based on web. But there's pros and cons for that as well. So I'd say the decision is going to be, the base is going to either be JavaScript or .NET Core in this case, because both of them are evolving. Both of them are the most cross-platform languages out there. .NET is a million miles apart from any language that exists for debugging, speed, function, everything. .NET Core is where it is right now, basically. And I've been using it since DNX when it first got, you know, suggested, the community started taking up before it was called .NET Core, and I've seen it progress to this stage, and it's really evolving rapidly. It's the most exciting language, if you will, that I've seen, and it's amazing how unaware a lot of people are of it, and also of the power. So my natural instinct is to go towards a .NET Core base, with some possibility that we actually go directly with a web-based technology from the start and go universally cross-platform. So let's just talk about that for a minute and see. So the options we have are Xamarin, which, again, long-winded story, back to the start now. The reason Xamarin would be the cross-platform for mobile is because it allows us to link in with .NET Core. So let's say we used a .NET Core layer for our majority of our language, and now we need to make the UI link in with this. So to link the UI with .NET Core, Xamarin comes along, and that's what we can use. You look for alternative to Xamarin, like many will, because unfortunately Xamarin isn't great. It's slow, it's buggy, it's not very performant, even though they have the big splash about native performance, and it's terrible. It was worse 5 years ago, it was worse 3 years ago. Microsoft brought it a while back. It's still bad. It's better, but it's still bad. But it's the best of a choice of bad options if you want to do a .NET Core base layer, I'm afraid. It's kind of where we're at. But the drive for using Xamarin is not because Xamarin's good as such. It's simply because of all the other benefits of using a .NET language for the rest of your product line. There's just so many more benefits to the Visual Studio experience, the debugging experience, the speed, the support. All that drives us towards Xamarin. But yes, if an option for using .NET Core and then building the UI on some other technology come along, Xamarin will be dropped in a heartbeat. So Xamarin's the only option I can see there for C#. Then we move on to web-based technologies, or in this case, Flutter's a kind of in-between. This, I'm not too excited about. I'd say this is more, again, of the hype. This is the kind of technology that comes about like Angular and React that people jump on and love and then realize it's useless, and then it fades out and other technologies come about. I feel Flutter, and no offense to it, yeah, it looks amazing, looks good, the UI is great, but I can see this being just a flourish, just another pop up and disappear technology. And obviously everybody that uses this will disagree, but I mean, look, it's made by Google. How many things have Google made that come and go? You know, they look great, then they just don't catch on, then they die. The language you're going to be using, is this the one that uses Dart, I believe? But basically it's JavaScript again. You can see it's just using imports, it's using modules, it's just chucked on top of JavaScript. Yeah, so Dart. So again, Dart isn't exactly that popular. It hasn't been around that long. It's just like Go language. You'll get people that love Go language and talk about it, but it's a step backwards. It's an outdated looking, terrible syntax language. It's performant in certain areas, but code isn't always just about performance. People love to debate that, oh yeah, but it's really performant and it outperforms this in this scenario. But as a developer day to day, you're not sitting there going, oh, I love how fast and performant this ugly code is. You're loving the environment, you're loving the themes, you're loving the new language features, the support, the building, the ability to share code. All those things far outweigh performance in 99% of cases. And even if they don't, I can guarantee you the code you write isn't as performant as it could be, and you're kind of defeating the point anyway if you really are on about being as performant as possible. So as much as I like the look of Flutter, it would work for Android and iOS, but then you've got the whole issue of everything else again. It's not cross-platform yet, and they're talking about making it cross-platform, but it isn't right now. And then your entire code base is stuck in this language that nobody uses, nobody talks about. So unfortunately, as much as I like the look of this, and visually, yeah, it looks great, I don't see the time invested in this. So that brings us on to really the only other option I've found that's a true option. And this is Ionic. And I think I saw it years ago, but then on Discord it got brought up again. And it's based on, obviously, if you see progressive web apps, then this is where you're basically using web technology. So you're using the browser, you're using JavaScript, you're using HTML, CSS, all your browser languages. But where the progressive web app comes in is there's two stages. One is that it actually responds naturally. You've got to respond to your platforms. And two is it starts to mingle in with the actual underlying operating system. So hence progressive, because it can run without it, and it should. But then when you can start accessing the underlying layers of the operating system, it can become a true application that actually works cross-platform. So that there's a lot more to it, but basically you can think of any progressive web app, which I do feel is possibly the future. It's one of two options that I do see as being the future of cross-platform development. You can build progressive web apps with no tools. You don't need this tool here. But this looks very promising. And I am genuinely tempted to potentially throw in the towel and say, do we do an Ionic-based universal, development, if you will, across the board, and just get entirely 100% stuck into this one framework that I haven't used yet to build the entire thing, which is risky? Or do we play it a little bit safer, do a .NET Core base layer, maybe WPF or Electron for the desktops, and a Xamarin for the mobile apps? I don't know. It's between them two options. It really is. Now, I love learning new things. I don't like Xamarin, but I love the .NET Core. I don't like JavaScript environment. I don't like its syntax. I don't like its organization. I don't like how you can't separate and grow projects very big, very easy. Visual Studio Code, I'm blown away by how they can actually build such a big app in JavaScript in as many files that are so messy, even in source code, are just all over the place. How they manage that, it kind of sets my OCD off. I'm like, it's just a messy, cluttered environment. And again, just because a big company use it and big things are made on top of stuff does not necessarily mean that they are good and the right way of doing things. So my slight fear with Ionic is it's going to be very similar. It's going to be kind of, in my eyes, potentially cluttered. And I don't know, I haven't used it, but that's my little fear there. It's also a fear that if you get so far into this and all of a sudden something's not possible, or there's a killer bug, or there's simply a feature not there, and your entire code base, your entire core, your universal core, your modules, everything is in this, you cannot port that over to .NET Core easily. In no way. I can tell you now that will not be an easy option. So this is I'd say a really high risk of putting the project at danger, but with the potential of being maybe on the cutting edge. Maybe when I started doing .NET Core when it was called DNX, that was the right decision because that turned out to be commercial by the time I got to commercial stage. This Ionic could potentially be the next commercial phase in development that just isn't there yet. In my eyes, this isn't there yet, but there's real potential. So it falls down to, I think, in my eyes, these two options. .NET Core backend with Xamarin. The watch apps are going to be what they're going to be. I've got a feeling no matter what, the watch apps are going to be built from scratch, and they're mainly going to be UI that simply talks to the phone. I don't think there's going to be a way to merge them in, and I don't think it's that big of a job to do them anyway. So that's why we're not talking about the watches. But in terms of the main languages, I think these are our two competitors. So let me know what you think. Comment and let me know. And honestly, I think I'll just leave this video open at this point, make a decision based on the chat that goes on in Discord and the decision we make, and then we'll jump into coding. So with that, we have our planned list of technologies and frameworks that we're going to start with. And next, we'll now make some blank applications, solutions, form this kind of structure of the application, now put the pieces together and get it compiling as kind of blank sections in code, ready to start working on. So any questions, do just comment. I'll get back to every one of them. And if I've helped you at all on this project, please do think about donating.